In this video, we're going to look at this question here, where we're given this curve, y is equal to 8 over x squared plus 4, and that curve is known as the Witch of Maria Agnesi, and it's named after an Italian mathematician who was known as being the first female to be offered a professorship at a university. So what we want to do is find the equation of the tangent line to this curve at the point when x equals 2, and then using a calculator graph the curve and the tangent line. So there's a couple of ways we can go about differentiating that function, but in this video we're going to differentiate it using the quotient rule, which I've got written out in this box up here. Okay, so if we've got y is equal to f of x, which is equal to 8 over x squared plus 4, well, that means then that the derivative f dash of x is going to be equal to, well, using our quotient rule formula, we've got v, which is our denominator, so that's the x squared plus 4, times the derivative of u, which is the numerator, and our numerator is 8, so the derivative of any constant is just 0, and then we're going to minus u, which was 8, times the derivative of v, and v is x squared plus 4, so using the power rule, that x squared becomes 2x, and then the 4, which is just a constant term, the derivative of any constant term is just 0, so we just get 2x. And that is all going to be over x squared plus 4 all squared. So simplifying this then, we're going to get that f dash of x is equal to, well, in the numerator we have x squared plus 4 times 0, so that's just 0. And then we've got minus 8 times 2x, so we're going to end up with minus 16x in the numerator, and it's going to be all over x squared plus 4 all squared. So we're wanting the equation of the tangent line at the point when x is equal to 2. So first of all, we'll find the gradient of the tangent line at x is equal to 2. So we have then at x equals 2 that f dash of 2 is equal to negative 16 times 2 over 2 squared plus 4 all squared, and that is equal to, well, negative 16 times 2 is negative 32, 2 squared is 4, so 4 plus 4 is 8, 8 squared is 64, and simplifying that we get negative 1 over 2. So the gradient of the tangent line at x equals 2 is negative 1 over 2, and now to find the equation of the line we're also going to need a point on the line. So we've got the x coordinate of a point on the line, x equals 2, so we just need to find what is the y coordinate when x equals 2. So at x is equal to 2, or y is going to equal f of 2, which is going to be equal to 8 over 2 squared plus 4, which is equal to, or in the denominator we have 2 squared, which is 4, plus 4 is 8, so we're going to get 8 over 8, which is equal to 1. Now in general, the equation of a straight line is given by y minus y1 is equal to m times x minus x1, where m is the gradient of the line and the x1, y1 are the coordinates of any point on the line. So for the equation of our tangent line here, we know that the gradient of the line is negative 1 over 2, and we've got the coordinates of a point on the line, so that would be the point 2, 1. So x1 would be equal to 2 and y1 is equal to 1. So the equation of our tangent line then is going to be y minus 1 is equal to negative 1 over 2 x minus 2. So just rearranging and simplifying this then, we're going to have y is equal to, so take that minus 1 to the other side, we're going to get 1, and then minus a half times x is minus 1 over 2x, and then minus a half times negative 2 is positive 1. And so we get then the equation of our tangent line is going to be y is equal to negative 1 over 2x plus 2. So that is our answer for the equation of the tangent line. So we'll bring up our calculator now and graph the curve and the tangent line. So for the curve, that was equal to 8 over x squared plus 4. Okay, so that's our curve there, and I'll just move this label over a little bit. And now to graph the tangent line, so that was equal to negative 1 over 2 times x plus 2. Okay, so there's our curve and the tangent line graph there. So we can just zoom in a little bit just to get a clearer view of what's going on. So if we zoom in, say about there, so there we can clearly see the curve and the tangent line there at x equals 2. Okay, so that finishes this question here. So we've used the quotient rule to differentiate that function there, y equals 8 over x squared plus 4, and then we found the equation of the tangent line to this curve at the point x equals 2.